Welcome back to the channel. In this lecture series, we'll discuss about topics from engineering graphics. First off, in order to get to the engineering graphics, its core concepts, we need to know the first. We need to know the basics. So we'll start with projection of points. So before we started, let's discuss about what we need to know before we start with the projection of points. Okay. Let's say if I want to you to get an object from somewhere, what are things that are required? I need to explain to you what that object is and where it is and where it is in respect. I mean where it is in respect to the person, and also give him a reference to get that also, right? So orthographic projection of points in this. In order to draw a projection of an object, we need some basic information. That is, we need to know what that object is. So we need to create clear description of that. Followed by that, we need to know where the observer is. It should be perpendicular to the respective reference plane. And then we need to know what is the location of the object. So if it is like where it's positioned with respect to like the horizontal plane or vertical plane. So what is horizontal plane, vertical plane? This we'll discuss further. So horizontal plane is we know that horizontal is nothing but this way, right? So horizontal plane is nothing but it is an imaginary plane which we will use to find out if the given object is above it or below it. Then we have another thing called vertical plane represented by VP. So vertical plane is it's an imaginary plane that is perpendicular to the horizontal plane. So we have an imaginary plane that is vertical. So the probability of the object being in this with respect to this is either it should be in front of the vertical plane or it is behind the vertical plane. So with these we can find, so we can form like four quadrants, that is 1, 2, 3 and 4. So we can form like four quadrants similar to what we have in the graphical representation method. So it will be interesting to learn what are the different positions, or what are the different views that can be drawn using these quadrants. So while we draw, it is important to know the notations of where your object lies, and based on the orthographic projections and the views it is in, we have to represent it in such a way that we can identify based on the notation where the position is and where the point actually is. Okay, so the first thing is there are different views when you draw an object. So imagine you have let's say a box or whatever object that is. So what are the different ways you can look at it in like 90 degrees sort of angles, like that is called the orthographic projections. So you can see it in the like 3D way, you can just rotate it around, or what you can do is you can see the 90-degree versions of views of the same object. So first thing what you can do is getting the object, you can look it from the top. So that is the top view. Then we have the front view. So opposite of top view is the bottom view. So you can look at the bottom, and then you have the front view. So let's assume you have your smartphone, and where do you use your which part of your smartphone do you use to access the user interface and all the like the touch swipe and all of these things? Use it, we use the front portion of the mobile, right? So if you consider that as the front part, then the top portion of your mobile is the top view. I mean, when you look at it from the top, you can see the top portion of your mobile, and the bottom view will be the portion where most of your mobile's charger will go. Charger pin, the C-type part will be, and you will have the right side view and left side view, right? Okay, so that is what we are going to use to first off start with the line, and then move on to, I mean, start with the point and then move on to lines. So top view we have A. So whatever point that is there in the top view, it is represented as is. So if it is point A, if it is point P, if it is point X, it stays as is. If it is a line on the when we look at it from the top view, it stays as the same thing. So it will be represented by the 2 points AB, PQ, RS, and so on. If it is in the front view, we have to mark it with a dash. So if the point is there in the front view, it is denoted by a dash. So we call it A dash, P dash, or whatever we name, whatever notation we give for that particular point. Similarly, if we have multiple points and they are connected together, it will be called A dash, B dash. So we give dash to both the points. Since it is a connection, it is a set of 2 points connected together, we have to give dash to both the points. Then if we look at its side view, then it should be represented with double dash. So if the point is represented with double dash, if there are 2 points and they are connected by a line, then the line will be represented as A double dash, B double dash. Simple. So if you look at it from the top, and if there is a point, it is the point is labeled A. It is a point A. If there are multiple points and they are connected together by a line, then it is represented by that. Let's say if we have point A and point B, then it is the line is AB. If we are looking at the front view, if there is a point A, then it is A dash, represented as A dash. We are looking at the A from the front view, right? So it is A dash. So if there are multiple points connected to there, then it is A dash, B dash. So let's have sort of a cheat code to remember this. So we'll say top view is the first thing. So first thing we'll see from top, and then look at it front, and then look at it from the side. So this will be our steps. First one is top, second is front view, and third is the side view. So in this order, so A is first one is top view. So the notation stays as whatever label we give, and for the front view we give a dash. So that is the second step. For the third step, it is side view, right? So for that, double dash. Is that clear? Okay. Okay. So here, as I said earlier, we have the vertical plane and horizontal plane represented as HP and VP. So we start with this as the first one. So you remember in the graph system, right? So here we have all positive and all negative, positive, positive, negative, positive, negative x and negative y, and here we have positive x and negative y. So this was what you used to we used to have in the like graph system, right? So similarly, we start with first quadrant, second quadrant, third, and fourth. So if the observer is looking at the object from the first quadrant, say from this quadrant of our axis, then this sort of view is called first angle projection. So this view is called first angle view, and if we project all the points from the observer's point of view from the first quadrant, then it is called first angle projection, right? So we have the vertical plane and horizontal plane, right? So we need to represent them with a simpler sort of representation. You see this x and this y. We'll take this. So we'll take this line and then use it to represent the points. So for projection of points, a point may be situated in space. So we know that it can be in any four quadrants in the two principal planes. It can lie on these planes or it can be within these planes. So the projection is obtained by extending the points to the corresponding perpendicular planes. So one of the planes must be rotated so that first angle view or third angle view can be fit to that. So the projection are shown with flatter surface. So in order to avoid the we cannot draw or represent a 2D diagram, 3D diagram in 2D space, right? So in order to represent in 2D space, we flip it so that we can see all the quadrants. So projection of point in different quadrants. The point is situated in first quadrant. So it can be like the point, the different way options are, it can be first quadrant, second quadrant, third quadrant, or fourth quadrant. So mostly we'll use this one. See here, in this one, this point A is above HP and in front of VP, right? So what we do is, since this point is, this is the front view, right? So here we see this point is uh, this distance from uh, the vertical plane, and it is above HP, right? So what we do, we flip it this way so that we can represent where the point A is. So this part we will call it as point A in first quadrant. Similarly, we have for the second, third, and fourth quadrants. So for projections of a point in first quadrant, so if we'll see what are the different cases where if the point, if a given point is with respect to HP and VP. So assuming this is the front view and this is the top view. So if an object, if the point is in front of VP and above HP, so it will be situated here. So what happens is, if this is flipped this way, so you can see here. So in front of VP becomes this way, and this is above HP. So it is represented this way. So point A is above HP and in front of VP. So front view is represented this way, and above HP is represented here. So we'll move on a little bit to see problems. So here the first problem is A. In the A is on HP and 20 mm behind VP. So see, you can see here A is, it is on HP and 20 mm behind VP. So okay, we'll have another cheat code. So um, let's see what. Okay, let's see the first part, HP. So if what are the options for a point to be with respect to HP? It can be either above that or below that, right? Okay. So uh, if the given object, so for, a shortcut for that is, if the object is here in HP with respect to HP, all everything is positive in positive connotation. So if it is above HP, so usually you consider above as positive and below as negative, right? So in case of HP, if it is above, it is above the XY line, the reference line. If it is below HP, it is considered negative, so it is below the below the reference line. Coming to vertical plane, the options are either in front of VP or behind VP. So here it is opposite. So if it is in front of, it is below the reference line. If it is behind VP, it is above the reference line. Is it clear? I repeat again. For horizontal plane, if it is above, it is above. And if it is below the HP, it is below HP. I mean below the reference plane. And if it is in front of VP, it is below the reference line, as it is opposite. So below, in front of is positive, right? But with vertical plane it is opposite. So it is below the reference line. If it is behind VP, it is above the reference line. Is it clear? You can write it down. So when these sort of questions are given, you can just straight away just use that and plug it in, plug the values in, and put the points wherever it is. Okay, so we draw a straight reference line XY, and then in the first question it says it is in HP. So this, so if it is in HP, you draw it over here. So we are drawing on the reference plane only. And then if it is 20 mm above, I mean 20 mm behind VP. So what is behind? Behind is negative, right? So negative of negative is positive. So it is above the reference line. So here it is 20 mm above the reference line. So 20 mm is nothing but 2 centimeters. So when you draw, use your scale and draw 2 centimeter. So the point is 2 centimeter above this reference line. Okay, let's get to the second one. 40 mm above HP and 25 mm in front of VP. 40 mm above HP, obviously it is above HP and we get B dash, and 25 mm in front of VP. 25 in front. So in front is positive. So positive multiplied by negative is negative. So we get the value as below the reference line. 25 mm below the reference. That is 2.5 centimeter below the reference line. So similarly, try to solve these questions from A to G. So if the point is on the HP or VP, you should position it on the reference line. As you can see here, here it is on HP, so we drew A dash as here. Here both HP and VP are, I mean the point both are in HP and VP. So here we draw it over here. I hope it is clear to everyone. Try to solve these questions and put it in the comments below. Thank you.